This is our second video in Chapter 2, looking at the nomenclature of inorganic compounds. We just looked at naming ions, and now we're going to put the cation and anion names together. We're going to learn how to name ionic compounds. Ionic compounds, sorry about that. Remember that ionic compounds are always compounds that are held together between attractive forces of the cations and anions. So ionic compounds themselves are always going to be neutral. The overall net charge of the compound is going to be 0. And there are charges within the compound, though. We know that cations have some positive charge and anions have some negative charge. So the sum of these charges combined will equal 0. When you look at ionic compounds, remember that ionic compounds exist in ionic lattices, and the compounds are held together by attractive forces, not actual physical bonds that kind of glue or hold the ions together. It's just a force of attraction. So when the crystals form, they form in such a way where several cations and anions will combine to neutralize the overall net charge in several different various three-dimensional shapes. So when we look at the ionic formula of a compound, we don't have a specific molecule with a certain number of each atom or ion type attached. We're going to look at the simplest whole number ratio of each of the ions in the compound. For example, if I took a little piece of salt, sodium chloride, NaCl, sodium chloride exists in a crystal structure, and if I just found a little, the smallest piece of salt I could find, chances are I would not get one sodium cation and one chloride ion. Perhaps for every one sodium chloride or sodium ion, I would get one chloride ion. So if I picked up a piece of salt, maybe if there was 100 sodium cations in that structure, there would also be 100 chloride ions in that structure as well. The simplest formula would always be 1:1. The formula of an ionic compound is always the simplest whole number ratio of the atoms you put together. Let's see here. So how am I going to write the formulas? Well, there's a procedure that we're going to follow down here for learning to write formulas of compounds given their names. We just talked about the charges, the ions in the group A metals and the group A nonmetals will take on. So what we're going to do is we're just going to work on balancing those charges to come up with a whole number ratio of cations to anions to get an overall net charge of 0. That's going to be the key. So what are the steps for writing a balanced formula for an overall charge of 0? Number 1, we're going to write the formula for the cation first. This will be the metal element, and will have some positive charge. I just put positive X there for the metal. For instance, lithium is +1, barium +2, aluminum +3, Al 3+. So we're always going to write the formula for the cation first. Whatever cation we hear, we're going to write the symbol for that cation, followed by its charge. Then we're going to write the formula of the anion. The anion is usually a nonmetal, and it will have the negative charge. So for instance, chloride, Cl -1, sulfide, S2 negative, it's in group 6A. So we're just going to write those two down side by side. What we're going to do next is we're going to combine the smallest numbers of each ion that's needed to get a charge sum equal to 0. So the overall charge is going to equal 0. Finally, we're going to write the formula of the compound as the symbol, just the symbol of the cation, and the symbol of the anion, which is the nonmetal. And we're going to use subscripts to indicate the number of each cation or anion, metal or nonmetal, in the formula. So I might use A and B here for my subscripts. This is the number of each you'll need to balance the charges. So in the final formula of the compound, notice there are no charges written. The overall charge is going to be equal to 0. So let's look at an example, because I think examples are the best way to learn in this chapter. So our first example here, the ionic compound we're going to look at is zinc oxide. Now you might be asking yourself at first, how in the world did you know that was an ionic compound? Because I also know there's molecular compounds too. Remember from our previous chapters that ionic compounds always contain a metal bonded with one or more nonmetals. So zinc is a metal, oxygen, oxide, there's your nonmetal. So we know this is an ionic compound. So let's write the formula for zinc oxide. The first thing we're going to do is we're going to write the formula for the cation. That'll be the metal. So here we have zinc. What is the formula or the charge for zinc? If you recall, I'm not going to flip between the periodic table on the video, but have a periodic table beside you. On the very right-hand side of the transition metals, remember that we said that zinc was one of the 3 transition metals that has one charge only. So we always know its charge. It's +2. So zinc's in group 2b, it's +2 charge. It's followed by oxide. The I is the anion of oxygen. So we're going to write the formula for the anion next. Oxygen's in group 6a, so 6 minus 8 is -2. So that's the charge for oxygen is -2, according to the charges we learned in the last video. Alright, so now I've written the beginnings. This is kind of trying to figure out how we're going to start balancing charges. So we've written the formulas for the cation, we wrote the formula for the anion. Now what we have to do is number 2, combine the smallest numbers of each ion to give the charge sum combined, which is equal to 0. I think this one's pretty easy to see. If we have one zinc, which has a +2 charge, and we add in one oxygen atom, which has a -2 charge, we can simplify this. 2 plus -2 will equal 0. So here, if we have one zinc and one oxygen, the total charge will equal 0. I think this is one of the easiest cases to see, though. I think it's pretty clear to see that the overall charge of +2 and -2, they're equal and opposite, is 0. So basically, we only need one of these. So that will tell us that we need to, once we figured out how many of each ion we need to balance the charge, which is just one of each, we're going to write the formula of the compound. So the formula of the compound is always the metal, the cation, and the anion, and then the subscripts of how many of each we need. I will say that we're not going to write the ones down. You never typically write a subscript of 1 down. If there's not a subscript, you just say it's one of each. So here, the formula of zinc oxide is the untitled. That one's pretty easy. Let's move to the next one. Alright, here's our next compound. Calcium chloride. Calcium chloride. Now, first you have to say, what kind of compound do I have here? Because in the end, we're going to have a lot of compounds at the end of the chapter. So we have calcium, which is a metal, from the left-hand side of the periodic table. And then we have chloride. Chlorine's a non-metal on the right-hand side, so we have an ionic compound. So how do I write formulas for ionic compounds? I balance the charges. So let's do that. The first step will, of course, be writing the formulas for the cation and the anion first. So our cation is going to be the metal calcium ion. Calcium is in group 2A on the periodic table, so it has a +2 charge. The chlorine's in group 7A, 7 minus 8, -1, so it has a -1 charge. Alright, so we've written the formulas down for each. I clearly can see that right now I have a +2 charge and overall -1 charge. So my total charge for my positive is +2. Right now my charge for my negative anion is -1. So I need to figure out how many chlorines I need to equal -2. I think it's also easy to see that if I have 2 -1s, my total negative charge will be -2. So if I have 2 chloride anions, I'll have a -2 charge. If I have 1 calcium ion, I already have my +2 charge. So plus 2 minus 2 is going to equal 0. So if I have 2 chlorines, that will counterbalance the positive 2 charges. There's another way you can do this, actually. It's called the Crisscross Method. And you have to be careful with it, but it actually works pretty well. If you take the integer, like the -1 in the superscript on chlorine, and you cross that down as the subscript for the other atom, a 1, and then you take the integer 2 for calcium, and you crisscross that down for the chlorine, you're going to end up with Ca1, Cl2. This is actually the formula for calcium chloride. Basically, what we just showed a second ago was that one calcium has a plus 2 charge. If we add that to the chlorine, which has a -1 charge, but now we have 2 of them, plus 2 minus 2 equals 0. So the easy way to figure out the ionic charge is to just crisscross down the numbers from the tops of the charges down to the subscripts at the bottom. There's something you have to worry about here, though. When you do the crisscross method, rather than trying to algebraically figure out how to balance the charges, it's very easy. Except the last thing you always need to check is this the simplest whole number ratio? Because sometimes you'll get a multiple. I'm going to show you that in some other examples here. But is this ratio the simplest whole number ratio of ions in the ionic compound? So the ratio here would be 1 calcium for every 2 chlorines. And this is the simplest ratio. We cannot divide 1 by any other number, or else we don't get a whole number out. For instance, though, if I came up with a 2-to-2 ratio, that's not the simplest. You would need to take the crisscross formula you came up with, and you would simplify it down. So just be careful when you use this method that you simplify it overall. But this is the answer. Calcium chloride, you need 1 calcium cation for every 2 chlorine anions. Alright, let's go to the next one. The next compound that we're going to look at is aluminum sulfide. Aluminum sulfide. So aluminum is a metal, sulfur is a nonmetal, we have an ionic compound. So let's write the formula for the ionic compound. The first thing we're going to do is write the formula for the cation. Aluminum is in group 3A on the periodic table. It will have a plus 3 charge. Sulfur is in group 6A on the periodic table, so sulfide, 6 minus 8, has a -2 charge. Alright. Clearly here we have a plus 3 charge with a -2 charge. So we're going to need multiple atoms to solve this. What we're going to have to do is, right now we have a plus 3 charge and a -2. We know that does not equal 0. If we double the sulfur, though, if we have 2 sulfurs, we'll get -4. And that still will not solve the problem of having the plus 3 on the other side. So what we're going to have to do is we're going to have to balance the charges by finding the least common multiple. You probably remember doing this in math. The least common multiple of 3 and 2 is 6. So if I end up having an overall plus 6 charge and an overall minus 6 charge, I will have a net charge of 0. So the question is, if I have aluminum and it has a plus 3 charge, how many aluminum ions am I going to need to get a total charge of plus 6? Well, 3 times 2 is 6. So I'm going to need 2 aluminum to get a plus 6 charge. In the same way, if I need the least common multiple between 3 and 2 to be 6, my negative charge will have to be -6 overall. 2 times what is going to equal -6? 2 times 3 is -6. So I see that I'm going to need 2 aluminum ions for every 3 sulfur ions. When I do this, 3 times 2 will give me plus 6. -2 times 3 gives me -6. So I should suggest that my formula is going to be Al2S3. I need 2 aluminum cations for every 3 sulfur anions. Now, how would we have done this using the crisscross method? The crisscross method tends to be people's favorite. So let's try that. It is a really quick way of balancing charges. So we'll try using the crisscross method. We said aluminum was +3, and a sulfur ion is -2. With the crisscross method, remember that you're going to take the number from the charges in the superscripts, and you're going to drop them down, so crisscross them to become the subscripts of the number of each ion. So the 3 at the top here will become a 3 at the bottom, and the 2 at the top on sulfur will become a 2 at the bottom of aluminum. So overall then, what will be the formula again? In the final formula, you will not write the charges. So the final formula will be Al2S3. So we came up with earlier by using algebra to solve the problem. Al2S3, aluminum sulfide. So let's do some practice. Write the formulas for the compounds for the different ions. Here we have aluminum 3+, and fluoride with a -1 charge. So +3 overall -1, we need to make that a -3. So we're going to need 3 fluorides for every 1 aluminum. You could have used the crisscross method to get this. 3 will drop down, the 1 will drop down, and then you will get rid of the charges. So overall, our final answer will be AlF3, aluminum fluoride, AlF3, to balance the charges. Alright, what about calcium and nitrogen? Calcium has a +2 charge, nitrogen has a -3 charge. Okay, let's do the crisscross method this time. We're going to bring the 2 down, we're going to bring the 3 down. We're going to get rid of the charges. So overall, we're going to have Ca3N2. Now remember, when you use the crisscross method, always ask yourself, is this ratio a least common or least whole number ratio? Meaning, is 3 to 2 the simplest whole number ratio you can get? And it is. Neither one's divisible by itself. It's not like 6 to 4, which reduces to 3 to 2. So this is the simplest ratio. Alright, let's look at another one. Let's look at number 4 here. We have magnesium and iodide. So magnesium is Mg2+, iodide is I-1. Okay, so clearly we have a +2 charge if we have 1 magnesium. So how many iodides do we need to have a total of a -2 charge? Well, if each iodide is worth -1, we need 2 iodides to make a -2 charge to counterbalance the +2. You could have done this using the crisscross method as well. I try to teach more methods than one. But if you crisscross it down, you'll have 1 magnesium for every 2 iodides. Same thing we came up with here. In a 1-to-2 ratio, magnesium to iodide is the simplest ratio. Alright, let's look here. It says, what is the simplest ratio for beryllium fluoride? Well, beryllium is a metal. It's found in group 2A on the periodic table. So beryllium has a +2 charge. Fluoride, group 7A, has a -1 charge. So we're going to crisscross. We'll bring the 1 down, we'll bring the 2 down. We'll get rid of the charges. So beryllium fluoride will be Be, we're not going to write the 1, F2. BeF2. Alright, BeF2. Gotta erase. I like to write big. Alright, try writing some, well actually let's do this one, magnesium oxide, because this one's tricky. Magnesium oxide, let's write the formula. So we know magnesium is Mg, And magnesium, if you look on your periodic table, is in group 2A, so it has a +2 charge. Oxide, that's oxygen anion. Oxygen's in group 6A, 6 minus 8, -2. Now, you're probably going to clearly see when you look at this that the charge on the cation is equal and opposite the charge on the anion, +2 and -2. When that's the case, you only need one of each ion to balance each other. So the overall formula is MgO, and that's actually correct. But what I'm going to show you is that sometimes people will use the crisscross method, going quickly, because they love it so much. And when they do that, they'll pull a 2 down here, and they'll pull a 2 down here. And their formula will be Mg2O2. And they're like, yeah, I use the crisscross method, and that works all the time, right? Well, the crisscross method works, but remember, after you use the crisscross method to bring the charges down, you always have to ask yourself, is this the simplest ratio of atoms? Is 2 to 2 the simplest whole number ratio? No, 2 to 2 is the same thing when it's simplified as 1 to 1. So we need to reduce or simplify this formula to 1 to 1. So always use the crisscross method if you wish, if that's the method you choose to use. But just remember that sometimes, especially whenever the atoms are equal and opposite, that you might need to reduce the charges to get the simplest whole number ratio. Alright, so this is how you write formulas for ionic compounds.